So good afternoon. My name is Pavel Krivanek and I work for Bowing Schmidt, which is a German company in civil engineering. So they build bridges and railroads and other civil engineering stuff. I work for them via a small consulting company named Idea SRO. And in this presentation, I will talk about the documentation in Pharo and the support of technical documentation. I will focus mostly on the documentation that developers write for developers, not the documentation that we write for end users. But most of the things that I will talk about can be applied on this as well. So that's a well-known public secret that the developers do not like to write documentation. The main reason for that is that it's time-consuming and not really fun. When you program, you solve problems, you explore new ideas and do a lot of fun stuff, but then you need to sit down and write everything on the paper or on some document, and it's not fun anymore, and people do not like it. Moreover, if you write some documentation, it very quickly becomes outdated, and you need to all time check if it's up to date and modify it. That's the reason why a lot of people suppose that the documentation is not good, the best way how to document code, that the code itself is good enough for self-documentation of itself, which is not true. But for some simple cases, of course, it makes some value. On the other hand, some people say if we write a code, why do not let the tools make the documentation for us? So then they create vast sets of JavaDoc and Doxygen documents that no one reads anymore. But it's there, that's documentation, do whatever you want with that. And of course, there's also a problem that you need to ship features. So documentation is important, but the management wants often to see bug fixes and new features done. So the documentation is then quite overlooked from this perspective. And also, we all know that not everyone has Tolstoy's ink inside their body instead of blood. So not everyone is capable to write proper documentation. It needs a different skill set than regular programming. And also, if you are not native speaker in the language in which you write the documentation, it's one more barrier, and that may cause that you do not like it. But on the other hand, good quality and up-to-date documentation is important. I'm reminded about it every time when my colleagues ask me why is something like that what I did several months ago, and I often need to answer, I do not remember anymore. So that's why even in a Smalltalk world, we have a lot of attempts to do proper documentation systems. The most advanced is the Lapitter from GT, and Pharo 11 started to have a documentation browser which loads the documents from the external sources. Then just quick overview when we actually write the documentation. Often it's some time after. Then it's not the best thing because then it's mostly not finished anymore. then the other option is to do it for real. It's good, but then, as I said, it's not fun, and it takes extra time, which you should spend on. Pardon? Of course, but a lot of other things is as well. Then we need to. We have option to write to it during the documentation, but then it gets quickly outdated, and you need to rewrite it, and in the end, it's probably more work. Then there are some extreme approaches like TDD, that you write the documentation before you actually do something, but this approach is not well suited for the developer documentation, because you need to first explore the area that you look at to know what's going on. It's good if you describe the features for the users and use it as a source of tasks, but as I said, it's not good for developers. And the literate programming, everyone knows that you have an option just to write the documentation is the first thing, and the code itself is executable attachment to the documentation. And of course, you can combine it. Of course, not only programmers are struggling with writing of huge sets of documents. And it's worth to look outside. For example, there is a book which is named How to Take Smart Notes, which describes approach that Niklaus Luhmann, because it's German, psychologist, used for his academic writing and non-fiction writing. He was extremely productive. He collected so many materials that after his death, he published more books than many other people publish during their lifetime. And this method is based on so-named Zettelkasten. Zettelkasten is a note-taking system originally in the very old-fashioned analog way that you have the boxes with notes. But those notes were indexed. Every note had some ID, and you wrote some ideas, and you were able to refer to other notes by that ID. And the goal was not only to collect all the data, all the ideas, but sometimes sit down and think about those ideas. So it was used to let continuous growth your knowledge system. It served as exocortex, external memory. And in the end, when you collected all those notes about the topics that you want to write on, the final documents, you started to write the paper, but all the content you wanted was already somewhere on those notes. The only remaining task was to take this content and sort it, polish it, put it on the paper, and you were done. This is the best way how to do something. So if you are a student that wants to write a thesis or something like that, some papers, try to consider to read this book. It will provide you a lot of hints that are useful for your next career. And the question is, can we use a similar approach for the writing of the technical documentation? Before we will answer this question, let's look at what the computer program actually is, or take us another perspective on the computing systems. Here we have three methods. One uses calls the other one, so this one is implemented of this selector, and then we have another sender of do. And if you look at those methods, each one of them does something different. They are not completely the same, but they are similar. Each of those methods is similar to each other. So this one, if you go from this method, you see very similar view, just a method with same structure, or a very similar structure, same as blocks and so on. So then you may ask what other thing mathematics structure has the self-similarity feature, and that are the fractals. You may look at computer program as a fractal structure. If we go back, you may look at the method and may imagine that you dive in this selector, and you then see the other method. So you probably have seen many times videos of or direct computations of flying through fractals, and navigation through computer programs is the very same operation. And it's important to notice that this fractal representation, fractal structure, is there all the time independently on the actual representation of the code. If we have an extreme case of assembly code, it's just a set of instructions maximally with some labels. But if you are a programmer, you need to build this fractal structure in your head. And if you have better tools and better languages, it allows you to more go from this internal visualization of the fractal into something which more resembles to real flyby the system. So if you have standard programming language, text-based, it's like you would have a fractal on a given zoom level, and then you need to jump from one place to other, and it's not the way. Some tools do it better. If you look at our standard browser layout, I always ask myself why this invention, which is almost 50 years ago, 50 years old, still works so well. I have seen a lot of attempts to replace it in past in Newspeak and other IDs, but I found this approach to be still the best working for me. And when I created or imagined this screenshot, it was completely clear to me. It's like you have a fractal and with different zoom levels, and it allows you to easily know where you are, and you can open multiple such zooms on this fractal structure, and in the end very easily navigate and be aware where you are. But then the question is, if you have this code fractal, how to remember the path where you are, how to communicate it with other people. And the most natural one or standard one is to use the alphabetical order. Or you may or index the code by the order in which you wrote it, or by various code control flows. One method can be approached from multiple points, or from the TDD logic. So you write test and then go to the method that you are testing, and then go back, and the logic in which you write the tests is probably a little bit different than the order that is expressed by the alphabet. You have the dependency order and the order of loading and so on. And if we look what opportunities we have in Pharo, we have the alphabetical. We can sort methods by protocols, by variables, but we can see only one class. So you do not have an option to express code flow in the simple way. And of course, if we look at, for example, here we have set of tests, we completely lost the intention when we wrote those tests. So as I said, it had probably some logic. You slowly extend the system, and if you sort it alphabetically, all of that is lost. Then we write during the programming some quick notes, a lot of small bookmarks and so on. So that's other thing that we need to use some tool for. For example, the simple pen and paper. Or if we are debugging, the best way how to really understand something is to try to explain it to someone else. And if you do not have some colleague, the standard thing is the rubber duck. So you take it and explain the problem, which helps you to understand the problem. And it would be nice to be able to log this process of description. You can now do it quite easily with the text-to-speech systems that are available. Then, if you use the Pomodoro technique, it's very good approach to first in your session to write what you expect to do in those 25 minutes, or depending how long time you use, because then you track more better to your progress, and you also have better feeling what you can achieve next time in your workday. And every one of you probably knows the situation when you have something, you work on some hard problem, you dive into it, and someone or something interrupts you, and you need to read some mail or whatever else, and then you go back to your original problem, and you just need to start from scratch because everything is gone. So even if we write notes about this thought process, it helps to go back on track again. So we have those tasks, those operations that we do. We have the idea of documentation snippets based on the Zettelkasten. Then we have the code indexing. We can create the quick notes. We have the locked rubber duck, tracking of the thought process. And all those areas are quite similar. It's just text writing with references to code, with references to other texts and so on. So can we write simple and single tool to do that? So if yes, then we need a real proper good name, something cool which will attract users. So we thought about it, and we came with name the documentation support. You can find this project on the Bauschmidt GitHub account. And we first took those ideas and tried to make a simple prototype of it. And then we said to ourselves, we are too lazy, let's someone else do that, work on those bad ideas. So we asked Steph if he has someone who can work on it, and he said, yeah, we have some interns like Leo Frere that is quite capable, and he can help us with that. So we were lucky and happy that we do not need to write at all, and so we paid him to do some improvements on our original prototype. We wrote some vision and described the features that we want to be implemented, and he worked on that. And the resulting tool looks like this. As you see, it's very standard. It has the layout very similar to the documentation browser, and so it's quite familiar, but the internal logic is different. It's based on the microdown, so it doesn't use some cool rendering like the Lepitra does. You have simply one pane where you write the microdown, and the second with the preview. You can, with this button in the middle, show one or the other part. You can take the chapters as a standalone presenters, so you do not need to see all this window all the time. It's written in spec. It has the immediate preview. When you write, it gets updated, so it's immediately available. And if you have multiple windows opened on the same document, it gets updated at some time. And I would like to discuss a little bit the model. The basic unit of it is named chapter. I do not think it's the best name because we were thinking about names like documentation chunk or something else, because it should more resemble the note from the Zettelkasten and then just chapter from War and Peace. So we wanted to find some proper name, but in the end, the result should be some chapters. We stick in for this naming, and those chapters are free-flowing. The idea is that they do not need to be organized in some fancy way. They have keys that are unique. It's like UIDs, but if you write the chapter, you are not forced to title that. So the chapter name is not based on the title. You have the key, which is not changing, and you may change the title as you want and not name it at all, but it doesn't change anything. And those chapters are organized in the books and libraries. The idea is that if you have multiple projects in multiple repositories, each project can come with one or more libraries, and in the end you will all see them in the same window and move chapters between them, and that's just organization thing. but the basic unit is really the chapter. And to remind ourselves, you are not supposed to write one chapter as a long list from the beginning to the end, but instead of it, writes a lot of small chunks, and in the end, compose it to some proper document or store it somewhere else for later use and use search on that. The chapters themselves can be put into subchapters. So it can build hierarchical structure, but this structure is not set by the book in which they are. So the book itself is just a set of chapters, but the chapters know about each other, which allows more flexibility. Then we realized if you write some documentation, it's a good way to have sometimes a proper order, and in this way you can set one chapter as a follow-up of another one, and with this arrow button you can navigate through that. And everything, both of, if it's a subchapter or a next chapter, you can set by drag and drop, and you drag one chapter over each other, over another, and then choose what do you want to do. The chapters inside allow references to another chapters, and as you may see, the important thing is the ID of the chapter. The other option is to have a special kind of reference that in the end, during rendering, includes the other chapter inside the parent chapter. It's not like the subchapter always shows those subchapters inside, but you need to include it explicitly. And to more easily work with that, because you do not want to write those texts manually, you can just click on the buttons next to the chapter that will copy into the clipboard the proper reference, the inclusion reference or the normal one. For serialization, we tried to use, of course, the standard files, and in microdown format. You have the library, and each library has books, but the books are named by their ID. Identification. The real title of the book is in the sub file named the description MD, and the chapters themselves also are named only. The files are named only by that ID, and in the beginning there is a small header that contains metadata about the chapter. And in the end, the markdown itself, or microdown. This way, the structure is very flat. You have really the libraries, books, and chapters. There is no structure, so subchapters are not somehow placed in subfolders. This structure is, this serialization structure is friendly to other tools like file editors and GitHub views and other things. We also created some exported to those things, which is the Python documentation generator. The Massimo Certini did it, but it's mostly for only the user documentation outputs. It allows to create documentation in various formats after that. As I said, Leo worked on the proper search functionality. So if you look for some word, it shows you how many results do you have, in what chapters you can find them. You can quickly navigate, and with the next previous buttons, you can go through the found places. It's simply what you would expect from that. About more than 10 years ago, I created for the Nautilus browser the small tool named Periscope, which allowed you to have some bookmarks and other things like immediate preview of the methods that you are looking at in the browser. And I thought we should make something like that also for our system. So we have something named documentation context. It's just a very simple implementation now, but we want to improve that. And it's bound to Calypso. So when you are going through the methods or projects, classes, it tries to guess or determine at what you are looking at, and from that it finds the chapters that are mentioning the links to that method or class, and shows that. So in future we want to be able to show even the preview of the given part. And this way it makes the code and the documentation reference bidirectionally. Instead, but still you do not need to write some links into the code just because it's derived from the documentation perspective. It allows you to see what documentation entity is bound to your code. As I said, it's just the beginning. We have a lot of other ideas how to improve this side note. We can add bookmarks, and for example, it can log the order of tests that you executed manually, and so on. So it can be quite useful in the end. And because for several years Pharo has the option to open forms, morphs in the separate windows, I mean separate operating system windows. This allows you to take that opened window with the documentation and put it on the other monitor, which may be useful because now mostly everything happens on one window. You can try Open Calypso. It has still some problems, so the Pharo needs to be improved in this perspective, but the functionality is here, just we need to polish it. Because when you write documentation, yeah, we have time. Okay. When we write the documentation, at some point you export it to your Git repository, and it has a danger that you will lose some code because the image crashes or you forget to do that. So we create EPISA integration, which logs the changes that you are making to the chapters. Of course, it doesn't do it on each character level, because then by pressing each letter you would write it to the disk, and so it has some delay. You can still lose something, but it's no problem, I guess. And as I said, we store everything in the tonal format next to the tonal sources in the Git repository. This code, if Pablo and Gisha are here, look somewhere outside of the window, because it shows the way how we store the documentation as an external file. When I wanted to write it, I tried to look at the iceberg model, but in the end I found it's a better way to use the tool. So we call git commands from the command line, and then we create just a presenter for iceberg, and set up what should be selected, and explicitly press a button, and everything without actually opening of the presenter. So it's ugly hack, but it works. So it allows us to continue in writing our code, and at some point commit the documentation, and then continue with writing the code without needing to explicitly commit the code only to be able to commit the documentation. But of course, it's an external tool, so it will never have a good integration into the system. So if we rename the class, okay. So we, pardon for, I have a humble proposal. Let's make documentation the first class citizens in our ecosystem. Let's make them part of the Pharo language meta model. This way, we can improve our language in a huge amount without actually needing to change anything in the grammar or whatever else. Everyone else is using the file system and the files, and they are not able to do this. We can say, okay, our documentation entities are part of the language meta model, which means the tools are working with them, or the references or the refactorings work with them, and we do not say that the system that I presented here is the best approach. I want to say that it's a hint for the communication, for a discussion how such system should look like. So I will skip this one, and thank you for your attention. So do you have some questions?
When you compose information, do you, inside in the tree, do you display all the sub-elements, or is it something you are composing? And
by default, not. So if you want it, then you need to put the include references inside the parent chapter. But we can make probably some button which will do it for you, or maybe some element that will automatically say, if I have subchapters, do that. One thing is that we want it to be able to, the problem is what order of that needs to be there. So yeah, and so we didn't want it to put it into the book, because then when serialized and when we would work with that, everything would be messed by this order. I wanted the books to be just a simple store of those chapters. So that's something what we can, of course, improve. But not from the model perspective, but just the UI, I guess. Everyone else? Coffee break then. Okay. Thank you.
I have some ideas. It's like my issue with code as such is looking at me like yeah. My problem with code and people the problem with my code, I think it's just because they're approaching it. You understand? So if you see a piece of code and people want to see everything written out in small talk, all the English, of course, not everybody speaks English. It's another story, but then sometimes you want to see more like just the machine, the structure. Like I come from math, so I want to see the structure so I can see what's going on here as a machine. But I don't want to see F, G. I mean, I could do that, but having like 3 or 4 letters that are actually like linguistically indicative of what it's trying to do as well. So like I always thought language would be able to sort of like switch into different modes so that more descriptive, less descriptive. So when I first looked at it, I can sort of like kaleidoscope it out depending on. So in other words, rather than having a separate documentation area, just having the code itself able to transpose itself into something more descriptive if I want that.
Yeah. One problem is that the code is not always approached the same way. You can look at the same method from multiple perspectives, and then it makes sense to have really multiple external.
So the topological structure.
Yes, exactly. Okay.